Next topic is degree of freedom. Now, what is the meaning of degree of freedom and how is can to be calculated? Degree of freedom is actually the number of axes required to number of coordinate axes required to describe the motion of a particle. This is the degree of freedom. Suppose a thing is moving in a straight line, then to describe its motion, only one axis is required. So its degree of freedom is 1. Degree of freedom is represented by symbol F. Degree of freedom is represented by symbol F. Now, if suppose as I am writing on this plane, 2 axes are required to find out the position of that. So its degree of freedom is 2. Suppose a fly is flying in a room. To describe its motion, 3 axes are required. So that for that degree of freedom is 3. So degree of freedom is it is the number of independent coordinate axes. This is independent coordinate axis required to define the position and the orientation of a point. That is called degree of freedom. For the translation motion along x, y and z, degree of freedom is 1. We have different type of gases like monatomic gas, diatomic gas and triatomic gas. For monatomic gas, degree of freedom is 3. For diatomic, degree of freedom is 5 and for triatomic it is 7. This relation we will find by using the formula. There is a relationship between CV and internal energy. Specific heat capacity at constant volume is equals to derivative of internal energy, where U is representing here internal energy, where the formula for internal energy is degree of freedom by 2 into kT or RT. kT or RT. So you can also take R here for n number of particles. So from here, if we say for monoatomic or if we find a general relation, CV is equals to d by dt of F by 2 RT. By taking the derivative, we will get this. The formula for the U is F by 2 RT. Keep this formula in mind. For CV, F is constant because degree of freedom will remain same for a particular gas. 2 is a constant, R is a constant. Inside we get derivative. This is the derivative with respect to temperature. Derivative with respect to temperature. Inside we get this. This both get cancelled. So we get U is equals to F by 2 RT. CV equals to F by 2R. And there is a Mayer's equation that Cp minus Cv equals to R. So from here we get Cp is equals to R plus Cv. So if we substitute the value of the Cv here, we get F by 2 R. So we get what U is equals to F by 2 RT. Cv equals to F by 2 R and Cp is equals to F by 2 plus 1 bracket close R. If we say about the monoatomic gas, for monoatomic gas, F was 3. So we get U is equals to 3 by 2 RT. Cv is equals to 3 by 2 R. Cp is equals to 5 by 2 R. And to calculate, this is just R. And to calculate the specific heat capacity ratio, like heat capacity ratio, that is gamma. This is gamma. This is written by Cp by Cv. That will be 5 by 3. Similarly, we can find for the, by using this formula, we can find it for the diatomic gases at room temperature and at high temperature. So the expression what we get here, we get For monatomic, this is internal energy, this is Cv. For diatomic, this value we get, and for triatomic, this is the value for the Cp and U will get. Cv, Cu and U will get. Next, there is a relation between the gamma and degree of freedom, and that relation is given by this. This is the relation between degree of freedom and heat capacity ratio. This is the ratio between gamma is what? This is Cp by Cv. This is the relationship between this both. We can also find this relation. Gamma is equals to Cp by Cv, where Cp is equals to F by 2 plus 1 into R, where Cv is equals to F by 2 into R. This R get cancelled with this R. So F by 2 plus 1 upon F by 2 equals to gamma. If I separate out the LCM, I will get gamma is equals to, it was F by 2 plus 1 upon F by 2. This is 1 complete 1 plus 2 by F. Or we can say gamma is equals to F plus 2 upon F. This is a relationship between the degree of freedom and heat ratio. This is the relation that we get here.